In our previous video, we have seen that different measures of central tendency like mean, median, and mode alone are not enough to give us a good view over the data. We have seen that our cricket coach here was facing a problem to select his opener among Ramesh, Sonu, and Yadav, and how variance helped him to choose his opener.
Does all of this seem new to you? Then you might not have already watched our previous video on the variance, and I highly recommend you to go watch that previous video from the I section above.
Let's now say that Ramesh was left off the team owing to an injury, and thus Veer entered the game. His scorecard for the previous 10 innings are like this. And if we put Veer's score right next to Sonu's, we will see that Veer's performance is quite steady and he is quite consistent also. However, there is only one innings in which he has achieved a very low total. So, calculating the average of his dispersion with respect to the mean, that is variance, will not be fair, as one can have an unlucky day. This low score will obviously impact on the variance, as variance and standard deviation takes into account of all the values. Our approach should be to know how the dispersion of the central portion of the data looks like and tally these statistics side by side with Sonus. So, hello and welcome to the Sambodhi series of SETU, where we discuss several basic concepts of statistics, linear algebra, and machine learning. And in this video, we try to resolve this issue. In a previous video about percentile and percentages, we have already been introduced to quartiles. Now, what do you think that the difference between Q3 and Q1 represents? Pause this video here and think about the answer. The difference here represents the range from 25th percentile to the 75th percentile. That is, in simple words, the range of the central portion of the data, and dividing it by 2 gives us the quartile deviation. Quartile deviation measures how spread out or concentrated the middle 50% of the dataset is. Quartile deviation is actually less affected by outliers, as we are not considering the extreme data points, in this case, such as the player's unlucky poor performance in a match. Now we are actually rearranging the innings score of both Sonu and Veer into ascending order to get the Q1 and Q3 percentile, and thus calculating the quartile deviation for both the batsmen. Here we see that quartile deviation for Sonu is actually 5, which implies that the central part of his scorecard lies within a range of 5, whereas Veer's quartile deviation is 2, which gives the result that the central portion of Veer's scorecard is deviating a lot less than the Sonu's. Thus, it appears that even Veer had a regrettable rough one day. He may be a better option than Sonu because he is still more consistent in the area surrounding his average score. Therefore, if we suspect that there are outliers in the dataset, quartile deviation is preferred over standard deviation, as quartile deviation is less influenced by outliers compared to the standard deviation.
Thank you for watching this video till the end and hope you have grasped the importance of quartile from this video. Feel free to share your feedbacks in the comment section below and follow this series for more videos on different topics of the data world.